Hello friends, dear learners and my dear student. First of all, I take an opportunity to welcome you at my T.Y.B.Sc Analytical Chemistry class. I am Dr.S.R.Labhade working as Associate Professor in Chemistry at KTChem College, Nashik. Student, in previous lecture we discussed the different types of interference that likely to be occur in absorption measurement of the atomic species. That is the interference in atomic absorption spectrophotometry. We also discussed the remedies to overcome these difficulties or interference in atomic absorption spectrophotometry. In addition to this, we also discuss the advantages and disadvantages of the plain atomic absorption spectroscopy. Student, in today's lecture we discuss some important applications of plain atomic absorption spectroscopy as well as compare plain atomic absorption spectrophotometry with plain atomic emission spectrophotometry. Student, with different analytical parameters we can discuss first the atomic emission spectroscopic method and then we discuss atomic absorption spectrophotometric method. We know that plain atomic absorption spectrophotometry is a branch of atomic spectroscopy in which atomization of sample is carried out by using a thermal energy of the flame. In this case, sample is also excited by using a thermal energy of the flame. Energy of flame. Therefore, here atomic emission spectroscopy is useful for determination of those elements, those metals which are atomized and excited by thermal energy. And basically the alkali and alkaline earth metal will face this condition. Therefore, plain atomic emission spectroscopy is limited to determination of alkali and alkaline earth metals. Now here, qualitative analysis in plain atomic emission spectroscopy is done on the basis of wavelength of emission is identified. That is, wavelength of emission is the identity of the material, and with that wavelength of emission we can identify which type of material is present in the plane. Therefore, qualitative analysis is based on the isolation of emission wavelength. Then quantitative analysis is related with the determination of intensity or radiant power at the wavelength where sample shows emission. Therefore, emission intensity is directly proportional to concentration of analyte, and that is measured for quantitative analysis in plain atomic emission spectroscopy. While wavelength of emission lambda is useful for identification of atomic species present in the flame. Now here next up we can consider the selectivity and sensitivity. Compared to plain atomic absorption spectroscopy, plain atomic emission spectroscopy is less selective and sensitive for chemical analysis. That means here in this case, if we consider the selectivity that is related with wavelength of emission, Therefore, very metal eye shows emission at a specific wavelength. Therefore, spectral interference mainly occurs in the flame atomic emission spectroscopy, and that it decreases the selectivity of the measurement. As far as the sensitivity is concerned, it is a detection limit, concentration detection limit. Therefore, here this flame atomic emission spectroscopy is comparatively less sensitive because it measures up to ppm level concentration. ppm level concentration. Here, applications specifically, it is useful for the analysis of only alkali and alkaline earth metals. Therefore, here other non-metals cannot be determined by flame atomic emission spectroscopy, but by indirect method we can determine the non-metals by atomic absorption spectrophotometry. Now here other specification, that is, it is also a destructive technique, no molecular information. Therefore, here, with reference to this, here flame atomic emission spectroscopy, in which atomization and excitation is carried out by thermal energy of the flame. Therefore, it is useful for determination of those metals which are undergo thermal excitation and atomized by thermal temperature. Qualitative analysis is done on the basis of wavelength of emission, that is isolation of wavelength of emission. Quantitative analysis is done on the basis of measurement of intensity or radiant power of the emission, and selectivity and sensitivity is less compared to flame atomic absorption spectroscopy. Then applications, it is only useful for determination of alkaline earth metals which shows emission, but it is not suitable for determination of non-metals which does not show the radiation in the flame. Specifically, similar to flame atomic absorption spectroscopy, flame emission spectroscopy is also destructive technique, as it is a atomic spectroscopy does not provide the information about the molecular structure, and only elemental composition of sample is determined. Therefore, these are the points with which we can discuss the flame atomic absorption spectroscopy. Flame atomic absorption spectroscopy, in which atomization is carried out by the thermal energy of the flame or by electric furnace. Therefore, here, if flame temperature is not sufficient to atomize particular sample, then sample is externally atomized in an electric furnace, and atomic vapors of that particular sample are then introduced into flame for measurement of their absorbance. The excitation of sample is carried out by using a radiant energy provided by the source. Radiant energy provided by source, that is halocathode lamp or xenon arc lamp. Therefore, here xenon arc lamp, that is a continuous source, and halocathode lamp is a line source. Therefore, either by using a line source or a continuum source, we can excite the sample into the flame. As here sample is atomized by thermal energy by flame or electric furnace, it has a wide applications in determination of many metals. Therefore, metals, those about more than 70 metals are identified and estimated by this flame atomic absorption spectroscopy. While flame emission spectroscopy is limited to alkali and alkaline earth metals. Here elements are atomized by flame temperature or as well as by using an electric furnace, and those are excited by using a excitation energy. Therefore, qualitative analysis is done on the basis of wavelength of absorption. Wavelength of absorption, that is useful for qualitative analysis. Quantitative analysis is done on the basis of degrees in radiant power. Degrees in radiant power at a specific wavelength or by measuring the absorbance. Therefore, absorbance of a atomic species is measured for quantitative analysis. If we compare this selectivity and sensitivity, when we compare this with flame atomic emission spectroscopy, this flame atomic absorption spectroscopy has more selectivity. More selectivity means here we are using a halo cathode lamp. By using a halo cathode lamp, we can determine specific element in presence of other. Therefore, selectivity is more. Therefore, it is free from the spectral interference. Sensitivity, again it is measured the analyte concentration up to ppb level. ppb level, so that here it has a more sensitivity. Again, specifically it is useful for metals as well as metals by direct method and non-metals by indirect method. Therefore, direct method means metal directly measured. In indirect method, non-metals reacted with the metals and then concentrations of metal is determined. For example, chloride is determined by reacting with silver nitrate, and silver concentration is measured for determination of chloride ion. Similar to atomic absorption spectroscopy, similar to atomic emission spectroscopy, atomic absorption spectroscopy is also a destructive technique in which sample recovery is not possible. As well as this does not provide a molecular information, only gives the total concentration of element. Now this is a comparison between flame atomic absorption spectrophotometry and flame atomic emission spectrophotometry. Student, now we discuss the applications of flame atomic absorption spectroscopy. First is a qualitative analysis. Qualitative analysis is related with the measurement of the absorption line that is absorbed by the analyte element. In flame atomic absorption spectroscopy, the absorption line is the identity of the atomic species present in the flame. So the wavelength of absorption can be identified for qualitative analysis by using a continuum source of radiation. The wavelength at which that particular gaseous phase atom shows absorbance is identity. But here, main disadvantage of this, as absorption lines have bandwidth a highly sophisticated monochromatic system is required for the isolation of that particular absorption line. And in this way, in atomic absorption spectrophotometry, the qualitative analysis is carried out. But rarely flame atomic absorption spectroscopy is used for identification. Many measurements are carried out by using a halocathode lamp. Therefore, for selection of halocathode lamp, the analyte must be known. Therefore, qualitative analysis, that is a step already performed by other technique, then we can construct the halocathode lamp of that particular element, and then we can determine the amount of that analyte. And therefore, here flame atomic absorption spectroscopy rarely useful for a identification purpose, but it is a very selective, accurate and interference-free method of quantitative analysis of metal species up to ppb level. Now we discuss the quantitative applications. Quantitative analysis. Flame atomic absorption spectrophotometry, in which the absorbance of an absorption line is measured for determination of analyte. More than 70 elements are estimated by atomic absorption spectroscopy using their own halocathode lamp. Therefore, by using a continuum source, we can identify the particular analyte, and their concentration up to ppb level can be measured by constructing the halocathode lamp of the analyte. Special applications here in number 1, in metallurgical field, for analysis of alloy for their metal composition. Therefore, alloy that can be analyzed for determination of metal composition. What are the different metals present in the alloy? That is determined by flame atomic absorption spectroscopy. Alloy, that is a homogeneous solution of 2 or more metals. It is not a homogeneous mixture of 2 or more metals. It is a solution. Similarly, here analysis of ores and minerals are also done by this atomic absorption spectroscopy. In addition to this, it is useful in biological field, that is in a clinical laboratory, for analysis of blood, for determination of blood, for determination of iron in hemoglobin, as well as it is useful for analysis of urine to determine the level of cadmium and zinc in urine, as well as it is useful for analysis of hair sample for determination of cadmium or arsenic in hair sample. that can be estimated by this flame atomic absorption spectroscopy. Next application, that is in environmental field, analysis of environmental sample, analysis of environmental sample, such as elemental analysis of water analysis, that may be drinking water, polluted water, river water, sea water, that can be determined, that can be analyzed for determination of elemental content, particularly the metallic species present in the water sample. Similarly, it is useful for determination of some heavy metals in air sample, that is analysis of air. Here, air analyzed for determination of lead, because here lead, that is a material or lead particles are given from the automobile exhaust. Therefore, concentration of lead in air that can be increases, and lead concentration can be determined at a trace level by using this flame atomic absorption spectrophotometry. Student, now we discuss the special application of flame atomic absorption spectrophotometry, that is a cold vapor atomic absorption spectrophotometry for determination of amount of mercury in different samples. According to Food and Drug Administration, mercury level, Hg level set to a value 1 ppm in fish for consumption. And according to Environmental Protection Agency, Environmental Protection Agencies, this limit, mercury limit, is set to 0.1 ppm in drinking water and 0.1 milligram per meter cube in air sample. Therefore, to determine the level of mercury in fish for consumption purpose and level of mercury in drinking water and level of mercury in air sample, only the atomic absorption spectrophotometric method is best, because this trace concentration of the mercury is determined only by this method. Where we discuss the cold vapor atomic absorption spectrophotometry for determination of mercury in different samples. For determination of mercury in different samples, mercury is taken into a reaction mixture vessel. Here Hg sample plus HNO3 plus H2SO4. This mixture is digested and vapors of this mixture are then passed through another container where this Then after that, here a hydroxylamine sulfate and tin second sulfate, that is SnSO4, is added. And here air is flow through this solution, and finally this is given into a tube where the dehydration is carried out, that is a removal of here a anhydrous CaCl2 is present in this tube, therefore it absorbs the H2O, and this air is then given into a sample cell containing quad window. Here air out. The flow of air is 1 liter per minute. Here a halo cathode lamp is placed in front of this. This halo cathode lamp gives a line 235.7 nanometer, which is 235.7 nanometer, which is the absorption line of this mercury to detector and to monochromator and detector. This is a quad window because here these UV radiations are passed only through the quad cell. In this case, the mercury containing sample is taken into a flask. Initially the sample is digested with nitric acid and sulfuric acid. Then in same mixture hydroxylamine, and so that here mercury is get converted to mercury 2 plus. Then again a hydroxylamine or hydroxylamine sulfate or hydroxylamine hydrochloride or tin second sulfate is added to reduce this Hg to Hg. The vapors of this mercury are then passed by passing a air into a tube containing a anhydrous calcium chloride, and this air is then given in a sample cell, about 10 centimeter sample cell, and absorbance is measured for determination of mercury. This is a cold vapor technique that is most commonly employed for determination of mercury in different samples at a trace level. In this case, two measurements are carried out, one for the sample in a mercury and second for the standard sample of mercury. And from the absorbance of standard and sample, we can find out the concentration of sample or concentration of mercury in sample is equal to concentration of Hg in standard solution into absorbance of sample solution divided by absorbance of standard mercury. And in this way, the concentration of a mercury is determined. determined in. With our today's discussion, you can find out the answers of following questions. Question number 1. Compare flame atomic emission spectroscopy or with flame atomic absorption spectroscopy with respect to the different analytical parameters. Compare flame atomic absorption spectroscopy and atomic emission spectroscopy with reference to different analytical parameters. Second one, discuss the different applications. Discuss the different applications of atomic absorption spectroscopy and special application. Explain cold vapor atomic absorption spectrophotometry for determination of mercury in different sample. Student, with this we complete the total method of flame atomic absorption spectroscopy. Under this study we discuss first principle of atomic absorption spectroscopy, instrumentation of atomic absorption spectroscopy and working of atomic absorption spectrophotometry. After that we discuss the different types of interference and different applications of atomic absorption spectrophotometry. In addition to this, we discuss the advantages and disadvantages of atomic absorption spectrophotometry as well as we compare atomic absorption and atomic emission spectrophotometry. With this, we complete here the total atomic absorption and atomic emission spectrophotometry. Student, with this we complete the total syllabus of the third semester analytical chemistry course. Under this syllabus, we first discuss the gravimetric method of analysis, that is precipitation gravimetry. Then we discuss the electrogravimetric methods of analysis based on Faraday's law of electrolysis. After that, we discuss the thermal methods of analysis, that is again one type of gravimetric analysis. Then we discuss the polarographic technique of analysis. After that, we discuss the molecular absorption spectrophotometry, and at the end we discuss the flame atomic absorption and flame atomic emission as atomic spectroscopic methods of analysis. With this, we complete the total syllabus of the analytical chemistry of this term. With this, I wish you grand success for your university exam. Thanks for joining me. Keep learning. Happy learning.